Hi guys, welcome back to electricity. We're just going to look at the light bulb, and this is actually part 2, and we're going to look at just how it works. We know electrons go into it, okay, and then it lights up. Well, whoop-de-doo. How do electrons make the light bulb light up? Well, we're going to have a bit of a look at that. Off we go. Okay, I hope you already are sort of experts at light bulbs. You know they enter from down the bottom here on this part of the circuit, and they'll come out here and oh whoops, I've just broken, right, and they'll come out the side again. We'll just briefly review that. Okay, the electrons come in, up they come, through here, up here, along the circuit, through the tungsten filament. Okay, they actually slow down when they come through the tungsten filament. We'll talk about that. And of course then they come out the side, back to the battery. But of course, the really interesting bit is up here. What's going on in the tungsten filament? Why is it glowing bright and the rest of the light bulb, well, is just nothing seems to be happening? Okay, to do that, let's have a close look at the tungsten filament to see what's going on. And I thought I might just show you the flow of electrons there, just so you know what's going on. Okay, here's the light bulb. I'm just going to take a photo of this middle bit and make it big. There goes my photo. Okay, there it is, and I've made it big. Now let's have a look at what's going on. Okay, the electrons come from the bottom here. They're shooting up at a very fast speed. They're going very quickly. Whoosh, 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 whoosh. They're going along the copper wire, but then they hit the tungsten filament. Dun, dun, dun. The tungsten filament, I don't know if you know this, it actually doesn't conduct electrons as well as the copper. It actually resists a little bit. I'm going to show you what that means. But I've realised in order to do that, I'm going to have to make the tungsten filament even bigger. So let's take another photo of it and make it big. Here we go. I'm going to take a photo of the tungsten filament. Alright, here it is, the tungsten filament. I've zoomed in 100 times to make it big. It looks empty. It's not. I'm going to show you what it's full of. Look, it's full of atoms. Okay, and here come our electrons. They want to get through. Okay, I'm going to try some special effects. Forgive me here. Right, here comes the electron. There he goes. Bang! He hits that atom. Bang! He hits this atom. Bang! He hits that one. Bang! 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 He hits that one. Bang! Bang! He hits that one. Bang! 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 He's finally through. The next one. Bang! 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 They hit all the atoms. Bang! 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 Crash! Bang! 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 They're finally through. And by the way, there's another 20 million electrons coming through in the next second. Right, can you imagine what it would be like to be hit that many times by millions and millions of electrons? Okay, imagine maybe if you just put your hand on your arm and give it a hit and give it a rub and give it a hit and just interact with it and keep rubbing it. And I'm doing it now. I bet you've noticed your hand is feeling your arm is feeling a certain way. Go on, hit your arm, rub it, hit it, rub it, hit it, rub it. Pretend it's an electron crashing into an atom, hit it, rub it. It feels what? How does it feel? It feels hot, doesn't it? Okay, so let's just cover that. The electrons are crashing into and rubbing against the atoms in the tungsten filament. We saw that. Crash, bang, bang, crash, bang. When electrons hit something, or they hit atoms, they warm the atoms up. And remember, there's like 20 million electrons hitting this poor little atom. It gets hot. When atoms warm up enough, they start to burn or glow. And so, of course, the tungsten filament is made up of atoms, and it starts to burn and glow. Another way to put this is to say the electrons transfer some of their speed energy to the atoms, because they hit the atoms at a high speed, then they slow down, and then they rush off again. Okay, this is because they crash into the atoms and they make the atoms hot. So there is a bit of an exchange of energy going on. The electrons have a lot of speed energy, they crash into the atoms and they make the atoms hot. And the electrons lose some of that speed energy, but of course the atoms get hot because now they got hit by the electrons. And as soon as the electrons are clear of the atoms, they quickly speed up again as well because they're racing towards their best friends in the world, the protons. Whoosh, these guys are going right now. See you later, electrons, but of course, there's another 20 million coming through. And this is happening all the time, crashing into the atoms, warming them up, making them glow. So we have light in the kitchen or the bathroom. Okay, and another way of saying this is electrons transfer electrical energy, or just energy, to the tungsten filament in the light bulb, which transforms this into light and heat. Right? Electrons transfer energy, but it's electrical energy because we're talking about electrons, to the tungsten filament in the light bulb, which transforms this into light and heat. And if you wanted to transfer some energy into your arm right now, all you've got to do is get your hand and start slapping your forearm, and you will feel heat real quick. I'm doing it now. Give it a slap, give it a rub, give it a slap, give it a rub, you will feel heat. And if you're doing that, you are transferring energy to your forearm, which is of course turning that into light and heat. It's not energy you can really use very well, it just burns. But the tungsten filament, it fills the room with light. Right, and there's a picture of poor old Batman getting a burn from his evil friend Bane. Right, Bane is rubbing and twisting Batman's arm there, thereby causing friction, thereby causing heat to build up in Batman's arm, and that must feel pretty ordinary by the look on Batman's face. And if Bane kept doing that quickly and hard enough, well, the arm might just catch fire, but he's got to do it real quick and really hard. And in a sense, Batman's arm there is just like the tungsten filament, okay, because it's getting warmer and warmer and warmer and warmer, but of course the tungsten filament just burns brightly, whereas Batman's arm just gets redder and redder. But like I said, if Bane did it quickly enough, it would actually catch fire, but you'd have to do it quick. Alright guys, any questions, you can talk to me. Thank you very much. Cheers.